Welcome, everyone. For today's prep, we're going to start looking at the idea of concavity, so the shape of the graph of our function. So we're going to see start to look at what is concavity and, how do we find the intervals of concavity graphically just by looking at our function. And in the process here, we're going to see how to figure out these intervals of concavity given the graph of our function. And then we'll also see how to locate something called inflection points. So we're going to, see what all these definitions look like. And we're going to start with this idea of concavity. So concave up, concave down. So we say that at a point x equals c, the function f is concave up if the graph of the function lies above the tangent line at x equals c, and concave down if the graph of the function lies below the tangent line. So we'll come back and kind of fill in what the shapes look like in a second, but let's go to example 1. And we're going to start by looking at two graphs. And we're going to determine if the graph is concave up or concave down at a specific point. So let's look at the first one here. We have x equals c, and we find the corresponding point on our graph. And if we want to determine the concavity at this one specific point, what we can do is, draw the tangent line at this point. So let's do this. Let's draw our tangent line. And it looks like we're at a peak here, so the graph kind of momentarily levels off. So our tangent line is going to be flat. So let's draw this in. I can do better than that. All right, so there's our tangent line. And when we look at this, we have our tangent line at our point, we have our curve, and when we look at this, right around this point, the curve itself is sitting below the tangent line. So this first one is concave down. So the curve itself is literally below the tangent line when we're looking at this graph. Now, if we go to the other one, you can kind of guess this is going to be concave up. But let's draw our tangent line to see why. So we find the point on our graph at x equals c, and we draw, we'll do a little better. We actually go through the point there. That looks pretty good. And when we look at this, drawing our tangent line, and when we look at our point on the graph here, we see that our curve bends above the tangent line on either side. So the curve bends above on either side. Going back to the other one, the curve is bending below the tangent line. So this we say is concave up. So when we're looking at this graph, at this specific point, the curve of our function bends above the tangent line. And this kind of shape here is going to be how to think of concavity. It kind of tells us how our graph actually bends. So if we go back up to these definitions, concave up usually looks something like this. And we'll abbreviate this usually with CU, concave up. So it has this kind of cup shape to it. And that's kind of the way to remember this. Concave up like a cup. And almost like you could fill this up with water. Now, when we talk about concavity, it doesn't have to have this full kind of U shape. It might only be part of it. So it might be like just part of the U, the left side of the U, or the right side of the U, or maybe the whole, the whole U shape. Concave down, on the other hand, is going to have this kind of shape, and we'll a lot of times abbreviate this CD, concave down. So it might have the full kind of upside down U shape, or it might just have one side or the other. So it might look something like this, or it might look something like this. So this is concavity. So let's actually, we'll come back to inflection point, because this is going to lead to where we actually change concavity. So an inflection point, let's read through the definition. We'll come back and talk about this. But an inflection point is a point on the graph, a specific point on our graph, where our function is continuous, and more importantly, it changes concavity. So we go from either concave up to concave down, or vice versa. So let's look at the next example. Example 2. We're given the graph of a function y equals f of x, and we're going to figure out the intervals of concavity for this function, and we're going to figure out the inflection points. Where does this actually change shape? So let's actually go to our graph. And when we're doing this, we want to start by looking at sections of our graph where there's a clear bend. So if we remember, concave up is this U shape. And again, it doesn't have to be the full U shape. It could only be, one side or the other side. And concave down looks something like this. And again, it doesn't have to be the full thing. It could just be part of this. So we want to look for where our graph has kind of the most bend to it when we're trying to identify these intervals of concavity. And when we're looking at this, I would say this section right here kind of has a lot of bend going on. And this section right here has a lot of bend going on to it. And then we just try to match these up. So, if I imagine taking my concave down shape and just kind of sliding it around, and I just want to try to match them up. And if I look in this section right here, that looks to be a pretty good match. So right in this section, I would say that looks to be concave down. Now, if I try to match it up to the other section, I'm not getting too good of a match over here. So I can also go to my concave up and try matching that up, and I see that's a pretty good match right in here. But over here, it doesn't really match up very well. So I would label these sections. This section here that has a clear bend to it, that matched up nicely with our concave down. And then over here, this section matched up nicely with our concave up. And what has to happen is we have this section of our graph right in here that has a kind of a clear concave down bend to it. And then we have this section on the other side that has a clear concave up bend to it. And so what has to happen is there has to be a specific point somewhere in between those two sections where we actually specifically change over with our concavity. And it looks to me right about there, right somewhere in the middle there. Kind of hard to tell a lot of times by looking, exactly pinpointing where that point actually happens. We're going to see how to do this with calculus in the next section. But right now, we're just saying this section is clearly concave down, this section is clearly concave up, and so there's a specific point somewhere in the middle where we actually change concavity, and this is the inflection point. All right. So when we try to locate our intervals of concavity, we're going to kind of do this like we did with the intervals of increase-decrease. So we're going to start by kind of drawing the x-axis. So here's our x-axis, and it extends to minus infinity in one direction, plus infinity in the other direction. And we're going to start by plotting these points where kind of looks like it's concave up, or where it looks like we actually switch. So these inflection points. And it looks to me right around x equals 2. So we're just kind of estimating here. And so what this x equals 2 does is it splits up our x-axis into two intervals. We have this interval from minus infinity to 2, and then we have this interval from 2 to infinity. And what we decided by looking at the graph is that our function f on the left side was concave down. So if we go to the left over here, had that concave down bend. And then on the right side, it looked concave up. So we would say f is concave up on the interval 2 to infinity, and it's concave down on the interval from minus infinity to 2. So we're just listing our intervals there. Now we also wanted to find the inflection point. So we just want to be careful. So the notation here is we actually want to find the coordinates for a point. So if we look, the coordinate for this point looks to be, well, it happens at x equals 2. And then we just want to estimate what the y value is. And to me, that looks about 1.5. So our inflection point, we would say, f has an inflection point at 2, 1.5. So when we're doing these, sometimes we'll only specify the x value. Sometimes we'll actually specify both the x and y value for our point. So you just got to make sure you read the directions here. But it's important just to remember that as we're doing these, the notation kind of looks similar. These are actually intervals. So the intervals of concavity, where it's concave up, concave down, these are actually intervals. So think of these as like sections of the x-axis here. And when we actually list our inflection point, this is not an interval. This is actually just a point. So this is a point with an x-coordinate and a y-coordinate. So intervals, these are all x values, basically. So just be careful there with the notation. All right, so an inflection point, if we kind of go back up, inflection point, there's kind of 3 possibilities. We might have something like we just saw, where we have this point somewhere in the middle, and we have one section on the right that's clearly concave up, and one section on the left that's clearly concave down. Or we might have kind of the opposite. So we might have something that's clearly concave up on the left, and then we switch over to concave down on the right. So these are kind of some examples of what an inflection point looks like. And where to kind of identify this is you're looking for the sections that have the most bend to our graph, and then the inflection point happens kind of in the middle. And after all, when we're doing these, we're reading a graph. So we do kind of estimate here. You know, it might not exactly be clear. Is the inflection point right at x equals 2, or is it maybe a little bit off to the left here, or maybe is it a little bit off to the right here? So when we're reading a graph, it's just estimates. We're going to see, though, using derivatives, how we can pinpoint these locations exactly and know exactly where they happen. All right, so that's going to do it for today's prep, and we'll see you in class. Bye-bye.